everyone, we are talking about the reciprocal, quotient, and Pythagorean trigonometric identities today. So just to start, a little bit of review. So as we know, cotangent of x is 1 over tangent, cosecant, secant, they're the respective reciprocals of sine and cosine. And then tangent and cotangent are sine over cosine and cosine over sine respectively. So something that we know right off the bat is if I multiply tangent and cotangent, or if I multiply anything by its reciprocal, your answer should be 1 every time. Okay? So that's just a property of any function and its reciprocal. So moving on down a little bit, now let's move on to a little bit of proof. So just some very elementary proofs here. Hey, we're asked to prove that tangent equals secant over cosecant, and we're asked to prove that cotangent equals cosecant over secant. Now there's two ways that we can go about this. We can either manipulate the left side to show that the right side is true, or we can manipulate the right side and show that the left side is true. Either way, I think it'll be easiest in this case if we manipulate the right side and try to get to tangent. So what I'm going to do is literally box tangent, and keep in mind that this is my goal. So I'm trying to get my right side of the equation to equal tangent of x. The way that I'm going to do that is to rewrite everything in terms of sine and cosine. That's usually the easiest way to go about this. So I know that secant is the same thing as 1 over cosine. I know that cosecant is the same thing as 1 over sine. Okay. When I'm working with complex fractions like this, I know that dividing by a fraction is the same thing as multiplying by the reciprocal. So 1 over cosine divided by 1 over sine, same thing as 1 over cosine times sine over 1. So this is the same thing as sine of x over cosine, which I know is tangent. So I have shown that tangent of x equals tangent of x. I got to my goal, so I'm done with my proof. Okay, same thing we're going to do here. So I'm going to box cotangent of x as my goal and rewrite cosecant and secant in terms of sine and cosine. Okay, so cosecant is the same thing as 1 over sine. Secant is the same thing as 1 over cosine. I'm working with, again, a complex fraction. So I know that this is the same thing as just cosine over sine. And that cosine over sine is in fact cotangent of x. So I got to my goal and I have completed my proof. Okay, so in terms of the Pythagorean identities, we all know the Pythagorean theorem. Okay, just x squared plus y squared equals r squared. So this is the equation of a circle. Pythagorean theorem is the same thing. Hey, now if we divide both sides by r, I see that I have 1 on the right side of my equation, and as we know, the unit circle has a radius of 1. So now I have the equation of a circle, just kind of in conic form, if you remember the equation for an ellipse, and equal to 1 just meaning that I have a radius of 1. And as we remember, cosine relates to x, sine relates to y. Cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse, and that's exactly what x squared over r squared and y squared over r squared represent. Hey, x over r in this case represents adjacent over hypotenuse, where r is my hypotenuse. Y is the opposite side of my triangle over hypotenuse, again where r is the hypotenuse of my triangle, and so I just rewrite x over r as cosine and y over r as sine. And these quantities are both still squared, so they retain their squares. This is equal to 1. And so this is where the Pythagorean identity comes from. And typically we'll write this as sine squared of x plus cosine squared of x equals 1. Now, if I divide my Pythagorean identity by either sine or cosine, I end up with two different forms of the same Pythagorean identity involving tangent secant and cotangent cosecant. Okay, now these don't really have to be memorized because you can obtain them extremely easily just by dividing. Honestly, I never memorize them, but they're good to know. Now for some practice, the first thing we're asked to do is to transform sine times cotangent of x to cosine of x, or in other words, to prove that sine of x times cotangent of x is equal to cosine of x. So in this case, I'm going to box the right side. This is my goal. A lot of times when you're doing a proof, it's just easier when you have more things to work with. And again, I'm going to use my strategy of rewriting everything in terms of sine and cosine. So sine of x is obviously written in terms of sine. Cotangent is the same thing as cosine over sine. And if I cancel, I end up with cosine of x equals cosine of x, which I did get to my goal, so I have completed my proof. Okay, next I'm asked to transform cosine squared of x minus sine squared of x to 1 minus 2 sine squared of x. So again, I'm going to rewrite this just in proof form. Okay. Now, again, I'm going to box the right side and state that this is my goal. And when I look at this, I see that there's no cosines. So somehow I have to get rid of this cosine squared. And now I have 2 sine squareds. So a really good option would be to use the Pythagorean identity. So I have sine squared of x plus cosine squared of x equals 1. I know this. That means that cosine squared of x equals 1 minus sine squared of x. So if I can substitute this in to my equation, I will have gotten rid of cosine squared, and then I'll have 2 sine squareds. Right, so let's try that. I just substituted straight in for cosine. My negative sine squared x is still there. And now when I combine like terms, I'll end up with 2 sine squared x's. And this is equal to my goal. I've completed my proof. Okay, so the key here was acknowledging that I had to substitute cosine squared of x and use the Pythagorean identity. Okay, moving on. Next, they ask me to show cosine of m minus secant of m squared is equal to tangent squared of m minus sine squared of m. The m doesn't matter here. You could use x if you wanted. So again, I'm just going to rewrite this. Squared equals to tangent squared of m minus sine squared of m. Okay, so the first thing I notice is that this whole quantity is squared, whereas these are not. So I'm just going to distribute. I'll end up with cosine squared minus 2 cosine of m times secant of m, and then plus secant squared of m. Okay. Now I notice that cosine of m times secant of m is 1. So this will cancel out. And I'm left with cosine squared of m plus secant squared of m minus 2. Okay. Again, I can use my Pythagorean identity. So if I go back, I know that cosine squared of m is equal to 1 minus sine squared of m. Hey, my secant squared of m is tangent squared of m plus 1. Okay, and that's, again, just straight from the Pythagorean identity. So if I substitute both of these quantities in, I end up with 1 minus sine squared of m plus tangent squared of m plus 1 minus 2 is equal to, hopefully, this. And now when I do some simplification, I see that 1 plus 1 minus 2 is 0, so that cancels out. If I rearrange, I'll end up with tangent squared of m minus sine squared of m equaling tangent squared of m minus sine squared of m. So I did get to my goal here, which I did not box, so I'll do that now. Hey, I did get to my goal, and so I've completed my proof. Alright, last one is to show that sine of x times secant of x times cotangent of x is equal to 1. So quite obviously I will list 1 as my goal. It'd be kind of hard to work backwards from here, but I mean entirely possible. Again, I'm going to use my strategy of rewriting everything in terms of sine and cosine. So secant's the same thing as 1 over cosine of x. Cotangent is cosine of x over sine of x. And I'll just cancel things out. I get that 1 is equal to 1. I have reached my goal, and so I have completed my proof. Okay, Your homework is right below here, so if you have any questions, let me know, and have a great rest of your day.